So we are GDG Cloud Boston, and sorry for the delay again. And we are trying to help everybody along with us to get this ML certificate. Code of conduct: be nice to each other, be respectful, be happy, enjoy the time you have here and learn with us. And here we are. The agenda would be for us to basically go through this journey together, exam review, have some nice questions to go through. Hopefully we have the Kahoot working by that time. If you have any question, and also let's plan for another Power Week coming up. Where we are by now, this is week 2. So hopefully you were able to finish Google Cloud Big Data and Machine Learning Fundamental and how Google does machine learning. I noticed that some of the content has changed, but it shouldn't really impact you from basically getting the skill badge.
Can you pause for a second? They say you still don't hear any audio. Are you sure that you're unmuted, Lucas? Or? You say anything there? Okay, I hear it coming through.
Yeah, I mean, your audio is coming through. I think ours is too, and we're unmuted on this computer.
Okay, false alarm. It's working. I think that this person was incorrect. Sorry,
Okay.
carry on, please.
Sure. And there were, I think, about 8 labs that I'm hoping that you were able to go through them. So if you have any question, I haven't received anything to wrap the week, but if you have any question, I would be happy to help. And for the upcoming week, we want to launch into machine learning. So getting a little bit deeper into how to go through the data and the always beautiful TensorFlow and how to use this amazing library to our advantage. Exam guide review. Yes. So this week we are going to work on ML problem framing. And this is basically the essence of how you want to take a business problem. And so the initial part of it is the problem framing and use case discovery, which is color coded by blue. And this is where you feel data sitting somewhere and you know that you can make money out of it. And then, so now you know the problems. The next step for you is to go through this data that you think is, the next step is the data analytics and feasibility study. And that's where you are trying to basically, again, explore the data. So the initial part for you would be where you make sure that you have all of this data available to you. Because if you do not have data and you don't have a cheap way of getting this data, don't even think about doing ML. But if you confirm that you have this business problem and you have the data for it, now it is basically looking into it as a data science, making sure that this is feasible, this is doable. You have everything that you might need. And then it comes to selecting algorithm. I personally think this graph doesn't do justice because that data exploration time, the data exploration period, it should be like 80% of this whole graph, and everything else should squeeze in the other 20%. You need to stay there to really understand your data. Obviously, when you are seeing the data enough, you are able to make the correlation between the data and the answers and where you wanted to go from there, identify your algorithm, and start to generating features. This is really based on the type of problem that you are trying to solve. So suppose you want to make a model for cancer patient. How do you want to give this information of the CT scan to the model to handle? So that would be for you to identify this feature, this key point that you as a human would use to solve a problem, and how to numberize or turn them to numbers for your model to use them to make a decision. So obviously, if it's the tabular data, there are other methods of doing feature engineering. And you have the algorithm, you have the features, now you are building the model. Building the model requires you to evaluate it, otherwise you have no way of knowing what you are doing, and presenting the result, which all of it develops drops into the model development. And then also this part should, in my opinion, you might need to come back and basically hang in there a little bit further, because it's not a one-time process. You want to go back again and again, go to data, go to the model, and see how they are impacting each other. So when everything's done, plan for deployment, and basically operationalize this model. So now from this proof of concept, you can take it and you can really deploy it for future use. Constantly be required to monitor this model, because sky is the limit when it comes to the data, and you never can, as a scientist, you can confirm or ascertain that what type of data would come to your system. So always have these knobs to change and to go and make sure that, okay, everything's right and I'm not seeing something weird. Google provides you with this Vertex AI, which in my opinion has every single item that you need, from basically the initial part of this data wrangling and data exploration to ML development and to the evaluation. But particularly pay attention to everything that Google does for your data part. Data labeling, for instance, Google has their own system to label the data, and if you start working on it, you realize that labeling and annotating the data is the most expensive part of it. So Google has both automated and also people in the house to help you with the labeling, and it does give you a lot of new ideas with the feature source. So they basically give you a lot of information on how to do feature engineering. And there is this how if tool that we will go to later on, but that's a really cool visualization tool that also basically looks into all of the features that you can extract from your data. In addition to that, Google provides you with a lot of visualization tools that it doesn't get enough of maybe attention at the beginning, because as a research scientist, you are just like focused on making this model work, and that's the only thing that matters to you. And you know your model better than everybody else. You get to the point that this is your baby. You know all of the basically tips and tricks about it, and you lost connection to other people to be able to explain it to them. So Google have all of these visualization tool for you as a scientist to be able to translate your information to somebody who is in sales, marketing, or business part of the team, so you can carry this information for them to understand without having basically technical information. So framing a machine learning problem. Few questions to answer. What we are trying to predict and what is the data? So basically, what is the input and what is the output? The ML problem gets the navigation part of it, but you need to be clear on the input and output. The software problems, and basically how the user would access it, what type of service it is, and how is it done today and how you can improve it. And the data problem, which is obviously the hardest one, how you would collect this data and what type of analysis you need to be doing, and how to react to these changes. Basically, when the population changes, how do you want to deal with that?
So just want to interject on Thorne. Feel free to, if anyone has questions, just shout out. We're all here to talk together today.
I have one question related to data. So basically, even in the last workshop, right? I mean, the first module, in the first part, data prep part. So I mean, there is a functionality of transforming the data. So I mean, I was not able to like understand. So I mean, it is like extracting data and then transforming it in the Google Cloud. I'm asking this because I mean we don't know, right? Initially, what kind of transformations do we need? So, um,
I would say, if I understood your question correctly, your question is how from the beginning we know what type of basically function apply to the data to make it understandable for the model, right?
Yeah, so like my basic question is it a ETL or ELT system? Because extract transform load or extract load transform. Uh, because the way I have looked into it, it looks like ETL system. Because I'm looking at the data, then I'm transforming it, and then I can visualize it. So I mean, if that's
My experiments is always extract, transform, and then load.
okay.
But we have other expert here that
Yes,
might have.
you're both correct, that I think the model you showed last week isn't more of an ETL model. The difference is ELT is very popular these days where, for example, if you work with BigQuery and not necessarily, so idea of
ELT versus
ELT,
ETL. Yeah.
extract
Extract,
load, so
transform.
get it into the target system immediately, like BigQuery is your target system. So just take from cloud storage or CSV files, whatever you have, get it into BigQuery as soon as possible, and then do your transformations inside BigQuery. That's the only difference.
Yeah, it's
You
more like
still
an
have to do the
ELTL.
Load, transform.
Yeah.
Guess what? The T is always the hard part, right?
Yeah.
The transformation.
But
no
he's
matter
right.
where
I
you do
mean,
it,
if you
that's
have
the
the
hard
data
part.
in some non-BigQuery type place, then the only amount of transforming you need to do initially is so that you can put it into a tabular database.
Okay, so
And then you have it in the database, then you can do the real heavy transforming. Now that it's in a columnar database, you can do whatever you want to with it.
Okay, so
But if it
it's
was like in
just-
a text file, you wouldn't be able to do much with it in that format.
So I think you showed, the tool you showed last week is a way to use a GUI and not use SQL programming or other language programming that allows you to specify the transformations that you need on that particular data set. And then you can apply them with the secondary tooling that Google provides you, right? So that's one way to do the transformation part of the ETL. But a lot of big companies, if you have a data warehousing team and you have ETL people, you're going to write that in either Python or SQL or whatever, Java. It could be anything, right? It could be anything, any language you want, depending on the way your pipelines are structured. But for our purposes here, the kinds of transformations that you need to do are, and I think the ones we showed last week were like cleaning up some bad data and removing stuff that's irrelevant. But there's a second kind of transformation that you're going to come to, which is called feature engineering. And that's a kind of transformation also, right? So like, let's say you take lat and latitude, longitude. You have two columns for lat, long. Those together, did we do the city bikes example last week? I forgot.
I think that's this week. Yep.
I was maybe looking at something else. Anyway, the city bikes in New York is a common example that Google uses. So you have lat long columns that separately are not that useful. What you really want to do is combine them into a single indicator of location. And that's another kind of transformation. That's more like in the realm of feature engineering, because that new feature, that new data type becomes much more useful to determine distance from A to B rather than the individual lat long numbers. So you'll get to that, I'm sure.
I guess there's one thing I was wondering about the idea of like cloud storage and BigQuery and why those things are still important though, is like some of these manual tools for going in there and figuring out how to clean up the data are useful, but what if you have like 10 billion values, right, or trillions of values? That's where like something like BigQuery is really useful because it's built on a petabyte per second network, like the whole internet per second just for it.
But I think the main thing is like if you strictly think that your two options are ELT or ETL, like when you step back from the process, there might be multiple places where you're doing something that looks like ETL or ELT just to get it ready for the next stage where you do an even more involved version
So
of
it
that.
can be ETLT or something like
Yeah, exactly.
But all I was just gonna say is that you can make a productionized version of this that works at huge scale very fast, but then there's also like you got to figure it out day one, and that's where some of the simpler little tools are very useful.
Yeah,
exactly.
Sorry, back to you, Roy.
Thank you for that expert.
Is that Google Vertex AI will help us to react to changes in the trend? So is there some sort of monitoring on the data that gets feeds into the system? Because how are we going to monitor if there's a very change in the trends, right?
Again, I think
Very
the other
specific.
experts that we have are better in answering the question because I'm not the Google Cloud expert here. But if you, I before I go to them, I from my personal experiment, you are monitoring your system based on the response that you get from your customers, and they come back to you. At least in my personal experiment, they come back to you with, hey, we have this bunch of people that they have this specific data and your system picks on them and it's not right, so how to fix it, and that's what it's my experience, but please try
When you say
me.
that the four V's, right, the veracity, would this apply to that? Like you're trying to make sure that this data still makes sense?
Quality of data. Veracity, quality of data, basically.
Right.
But I think you make a good point. I mean, ultimately, you're building an AI model. You're going to feed it a bunch of information, and it's going to come up with something that you can't really explain, but it's based on that information. But then the way you know if that model works is you go apply it to a bunch of situations, and if it doesn't do what you want, then you have to do more engineering on the model. And so getting the feedback from your customers that it is or is not accomplishing what it's supposed to do is one of the feedback mechanisms where you're saying, oh, the model is not performing well, so we need to go do more work on the model. And, if you think about something we've all probably heard about recently, like with Bard and with Chat GPT or whatever, Chat GPT, they said that they had completed the training for GPT-4 6 months before they told anybody about GPT-4 because they wanted to test every scenario and see how it worked in different scenarios. And when it didn't do what they wanted it to do, then they went back to tweak it so that by the time users finally interacted with it, it was really behaving in a reasonable way that they expected. But that was a lot of back and forth of trying the model against this use case, seeing how well it performs, and then making the model better.
Fine-tuning.
Yeah, exactly.
I'm so lucky to have the experts here. So when I'm like, oh my god, how to answer that question? I graduated and then I started working as an ML scientist, but genuinely I think there are so many information that even if I'm so specific in just working on computer vision, I cannot think that I know everything about it. So I'm the luckiest person just to have Lucas, Norbert, and Joe here helping me out. And if I don't know something, I promise I will go and figure out. Okay. So jumping into development without a prototype or heuristic baseline. A machine learning project is an iterative process. You should start with a simple model and continue to refine it until you reach the goal. And a quick prototype can tell you a lot about hidden requirements, implementation challenges, and scope. I think that takes us back to where we started, that a machine, I think we discussed it last time, that if we cannot make sense of our data and we cannot get a result by seeing the data and making our own mind that, okay, what we are looking into to make a decision, we cannot expect the model to understand what to do, and we cannot translate what we want it to do to what model does for us. So I think it's a really great practice that always try to come up with this heuristic, which even if it's 18 lines of if conditions, do something for yourself to know, okay, I'm looking into these things. It helps you with future engineering, and it helps you to have a baseline. And sometimes, frankly, you figure out that you cannot even beat the heuristic that you wrote. So you either need more data, your data is not balanced, there can be so many issues, but it is not that a step to think that, oh my god, I shouldn't be doing it, people are not good at it, the machine can does it better. Again and again comes situation that people do it way better.
Question.
Yes.
So I understand that heuristic would be a quick way to get the answer to a prediction. So can you just give an example of what you mean when you said like a heuristic and like as compared to the model's prediction.
So I have a specific example, but I don't know how much I can talk about with NDA because it happened to me. So it happened to me recently that I had a heuristic for a computer vision algorithm, and just by looking at data, I knew which feature I should pick on and how to weight them together to basically get the result that I wanted. It was for a spoof detection algorithm,
Okay.
but the initial machine learning that we have done, which is basically, okay, get this image and determine whether this is a spoof or not, they couldn't beat it.
So a heuristic might just be like you look at the image and you see if it's a shoe, and then you see if the computer can tell if it's a shoe.
Okay, let me give you a specific example. I'm putting something together on the go. Imagine that you are trying to actually look into the shoe thing, but as a person, and with the data that you are already right now working on, you are just working on high heels. Okay, so you go for an edge detection, and you try to basically just find a high heel, and based on the distance, you say this is a shoe, this is not a shoe, right? Because, and maybe the ML that you are feeding it to, it's not that good in identifying high heel because it has seen other shoes too. So you have a heuristic that is good, which is a worse example that I made because now that I'm thinking about it, most probably the ML will pick on it. But if you don't have enough of images, if you don't have enough of input data, then it's a smaller chance that your model would pick on it. So your heuristic beats your ML. That's
we said
a
that
dumb
heuristic is a
example.
very simple solution, basically.
Yes,
It's a piece of logic, as opposed to like a whole neural network or something like that.
exactly.
Because I know, for example, it came out there was some lawsuit, like people like Apple was suing people because they stole their technology for detecting if the swipe was left or up. And eventually it came out that all the code in Apple's phone did is if it's greater than 27 degrees, it's up. That was their like secret patent sauce. So that's like a heuristic, right? There's nothing very complicated about it.
Yeah.
But you could have like a giant neural network to figure that out. You'd be like, wait, here's like one line of code that does it.
Okay.
And you can compare the two. Like if your model sees something that's more than 27 degrees and doesn't think it's up, then it might be suspect. That's a good call out. It's just like a basic thing that'll tell you like which answers seem like they're probably more accurate and which ones are not. And so yeah, something simple that just like you're filtering out certain results.
But I
Basically.
think Roy is saying that like if your simple thing is way better than your complex model, then okay, maybe your model, maybe you don't need a model, or maybe you're going the wrong way. Is that what you're saying?
Yes.
Yeah, somewhat like if you're Lyft and you're trying to predict the amount of tips based on the parameters of the ride, like the distance, the time of day, the weather, those could be all your features that you're going to look at for your tip prediction model. But your heuristic would be, well, what's the average tip? Like 15% or whatever, 15, 18%, whatever the average is. Overall, that's your heuristic. Boom. I could just predict, well, the tip's always going to be 15%. That's a really simple prediction. You're going to be in the ballpark, probably.
Yeah, you won't ever be 100% off,
Right. It's not going to be a really good model, but it won't be wildly off either.
And it's also probably
average.
what we did before we had machine learning. Was
Right.
like the algorithm wouldn't have had a model; it would have just had some fraction, or greater than, less than. And if it's between these two things, it's okay. And if it's outside of that, it's bad.
Yeah.
And now we have like a complicated model that gives us a like opaque answer that effectively might have the same outcome if your model is not much better than your heuristic.
So with the heuristic, you'll usually know why it was wrong because you'll see like, oh, well, this is, the heuristic you understand because you built it. The machine learning model is just spat out because of, what you used and how many responses you did.
Yeah, I mean, it's very difficult sometimes to answer the question of like, why did the model tell me that this was a shoe? But it is easy for you to tell if something is a shoe based on your idea. It's like no brainer, basically. So yeah.
Thank you.
Great questions. Thanks, everybody.
I got stuck on the thing. So the heuristic, um, I the deep learning can only do so much because it sees a lot of data, and that's as far as it can go. So the heuristic, even if it's not that easiest path of putting the numbers together, it really works for you to stay in. Particular, if you are working like on image data, um, there are so many like image processing algorithm that was before 2012, which was the AlexNet, which was this like big deep learning, which was great in image identification, object detection. If you know all of those algorithms and you put them in your heuristic right now, you are far better machine learning scientist than somebody who just puts things together and throws them at the model. Because if you know all of those, then you can make sense of why your machine learning makes this specific decision. And one example was a few years back. It goes from cat and identifies them as bear because it sees like this pinky pointy ears instead of like cats. So I think it worth to spend a little time on the heuristic, even if it's harder than what you expect it to be. Yeah. Okay, so let's start with an example. We are building a model to predict bike rental duration. The model's mean absolute error is 1200 seconds. Great. So it's about 20 minutes. But is it good or bad? So that's the example of the heuristic. Thank you. Simple point of comparison. Exactly. So it can be anything. It can be the constant. It can be a rule of thumb. It can be your simple statistic like mean, median, mode. It can be another person just like saying, hey, I'm labeling these things for you. So not necessarily determined by your ML, but you can always start with a linear regression as your easiest first base bench line. And I think these are more when you are dealing with tabular data.
I just have one quick technical question because I didn't understand when I was reading material the other night. They have MAE, mean average error. When I was going to school back in the Stone Age, we worked with like mean square error. Are they equivalent?
It's absolute error. Mean absolute
I
error.
understand, but does it mean absolute error like equivalent to like mean square error?
It's
No.
I think the
It's L1.
acute.
Mean square. I think it's L1, which is which is not squared basically.
I understand about the usage. Like, why would you use mean average error rather than mean square error? I was just curious.
So people, I can take a shot at this. Sometimes people have looked at the bias in how good those errors are in actually predicting how well the model is working. So mean squared is one way that's used comes from linear regression. But I'm trying to think of like the example of where like the student t-test differs from the standard deviation for small numbers.
Gotcha.
And so there's considered it's a little biased, but when you get out to large numbers, it becomes the same essentially.
Gotcha.
Things like that. So I think
well, I don't want to get too into the weeds. I just didn't know whether it's faster to compute, but the average would require a division, and the other is only multiplications. Anyway.
Yeah, it might be easier to compute if you're doing it by hand, but with computers, I don't think it makes
Okay. Well, anyway, I'll rest my
I
question.
pasted Bard's answer to this question into the Slack.
Oh, thanks. Okay.
Oh, good.
Okay, sorry. Back to our program.
In Slack, you can decide whether Bard is accurate or not.
probably better than
One thing that I remember, if I remember correctly, because it's acute at 0 and the other one is like a wall, it's penalized the smaller fault more.
I see.
I think that was the reason, but it's
it acts as a regularizer. Because if the weights are small, then it will penalize it more, and it will not make the model to be complicated. So,
It's under one. It's gets smaller.
yeah, so mean squared error doesn't penalize smaller weights that much.
Gotcha.
So,
Okay.
yeah.
Thank you. Thank you.
Okay, did I pass something? No. Okay, returning to the bike example. I love this session. We are having so many questions. In our training data set, what is the average rental duration given the station name and whether or not it is a peak commute hour? And how does our model performance compare to this benchmark? So that was just a question. So going back to the responsible AI, which was the best part of this, I think, presentation for today. For responsible AI is basically this umbrella term to cover fairness, explainability, privacy, and security. I want to take a moment to just stay here. When we started with AI like 10 years ago, I think everybody was so hyped to just move and move quickly that we didn't understand what we are not paying attention to. But just imagine like a banking app that tries to give you a loan based on AI. If you do not put thought in it to make your data balanced, you are definitely going to be biased against some people. Like they might be minorities, they might be going through some other challenges that you are not considering. So if you do not take the time, your model, although it looks good on paper, it's not the good thing that you think it is. Fairness. Understanding the reasons behind the model prediction can help ensure the model are treating all users fairly. And explainability is the process of understanding how and why a machine learning model is making prediction. So just to add to what we discussed, fairness is to treat everybody fairly, not essentially equally, but to consider what we as human would take into account when we want to make a decision. And explainability, that's like the hardest word. Explainability is not just treating this ML algorithm as a black box. I think we are getting rid of this word for some times now, but at the beginning, everybody was like, hey, I don't want to deal with ML because it's the black box. We don't know what's happening in there. I think still when we are dealing with these large language models, maybe we are a little bit behind on deciding why the model says something that it says. But about a lot of other models, about the models to make decision about the banking, like all of these tabular data particularly, or image detection data, it's a little bit easier to explain why the model does what it does.
And some of these stories are just so hilarious. Like I really enjoy the talks that are just about this bias in AI and just like the problems that come up. I can't remember the exact example, but I read something about, they were developing a model to be able to detect a cancerous skin situation. And like it turned out that it was recognizing that there was like a pencil or a rule. They have a ruler in the photo when there is something cancerous, and so it just learned that when you see a photo with a ruler in it, that means it's cancerous. And it was like that's what you talk about it. Like it seems to be guessing the right ones that they're cancerous, but why is it doing that? And it's not because it's recognizing the skin thing; it's because it's seeing the pencil or the ruler, and so that's really scary when you don't know anything about AI and you realize that even the people who are building the things don't necessarily totally understand how it works. It's understandable that there's a lot of people today that are like healthily afraid of this technology because they just don't know what to think of it. But yeah, I find so many of those stories like amazing. Or like, judging someone's IQ or some other model based on like whether they have glasses on in the picture or not versus whatever other characteristic it was looking for.
I guess I just throw out that you see a lot that also have like racial inequity though, because it'll be like, okay, this was trained on a training set of white students that were 22 years old from Stanford, which is not a representation of the population.
Right.
And then people that aren't that group, don't get the right outcome. So they get, lower weighting or so forth. And even there were things from years ago, I remember where ID stuff didn't work for black people because they didn't train it on darker skin tones.
I know that was the amazing thing is when I learned these things, I'm thinking about it in the context of this modern computer technology, AI. But it's like, 50 years ago, Kodak had produced a document that was used by every filmmaker to see if it worked properly. And it was like a picture of a white woman, and everyone made sure the film like showed that picture of that white woman really well, and everyone else like didn't show up in film, but they had never tried to like test it. And so it's the same problem, but it's even before you get to the point of AI.
Yeah.
It's just like this subliminal effect of having this one card that everyone is relying on and not understanding how biased the card is going to cause the entire industry and all the technology that's created out of it to be.
Back to the presentation. There are so many interesting discussions. Explainability evokes a variety of basically related concepts. So everything from transparency, accountability, traceability, human in the loop to make sure everything works right, contestability, interoperability, model lineage, auditability, and human in the loop. So the whole idea is you constantly make sure that the system is explainable, nothing goes wrong, the model is fair, and you know why the model makes the decision that it does. And because these ML model are not just for you as a scientist, you are the owner, you are the builder of the model, but it impact other people as basically the end user and also the public. Imagine like ChatGPT and the impact that it has on the education. I don't want to get into it because I'm pro ChatGPT and Bard in general. I don't think that they are going bad things for education, but at the same time, there was this interesting article that ChatGPT puts things together. I hope you take this off too. I'm saying so much.
There's a lot of editing on this video.
I can edit it myself. Yeah. ChatGPT makes reasonable argument, and it brings, for example, citation for them, but those citations they don't exist. And that's horrible because you are teaching children that these things is a fact. How many child do you know that they go for a citation? So
I will say that when I was a young student, when we didn't have the internet and we didn't have ChatGPT, we had like the World Book Encyclopedia, and the teacher was adamant that you needed to not rely on that book because it was not accurate. And so when you were writing your paper from that, you had to go like get additional sources to make sure it was correct. And so people have to do that now with ChatGPT, just like we had to do it back then.
We were trained to use a primary source.
Yeah,
not
exactly.
A secondary source.
Yeah, exactly. So I think it's like the new change on the skills. And another thing I'll say related to when I was a student was that I was in school when like graphing calculators came into existence. And in the beginning, when I was in high school, they forbid you from using them in a test or anything like that. But by the time my younger siblings were in high school, you were mandatory had to purchase a graphing calculator. And so I think we're going to see the same thing where like right now everyone is like, oh, my job's at risk. Oh, the students aren't learning because they're just using ChatGPT to write the paper. But in the real world, those people, when they're challenged at something at work that they're going to have to do, that tool is going to be there available next to them. They're not going to be without it in the same way that we aren't without our calculators when we need to do complicated calculus problems. It's not like we're forced to do it on paper ever. So you don't have to actually have the skill to be able to do it on paper the same way you did before. And so society will eventually realize that this is just one of the tools, like a calculator or a stapler that we have in our toolkit, and we'll adjust. But right now it's like, oh, all the students, one day they were writing the papers themselves, and then the next semester, every paper that they turn in is potentially written by a computer. And that's like a scary time to be involved during that transition.
Sure. I mean, if they want to cheat, they use check, so they just make it a little bit easier. Anyway, so we were talking about the explainability and fairness of the data, and who our model would basically impact. So it would be, aside from us, the end user and also the public, that they need to use a model which is fair, which is accessible, and which is basically safe to use. And it really depends on the type of data that you are using to make sure that the data does what you are expecting it to do. So for example, for the example that Lucas mentioned about that ruler by the skin cancer, right now you have tools for attention that they identify which part of they basically generate a heat map for your image and tell you what your model is looking into. I think that's the next slide. Yes. So what you are seeing for the image is basically the heat map of what the model used to identify why this image is a dark, and the part that is hotter basically is brighter. That's where the model paid more attention, and that's how they identified why the model picks all of the birds as cats. There was this model, this paper, amazing paper, Attention is All You Need. I think it's for 2016 or 2018, or maybe I'm totally wrong. Thank you. Yeah, I was like, I'm totally wrong. That really worth reading, and implementing it is not as hard, but it's something that if you are doing image detection, definitely have it in your toolbox. You want to know what your model sees. And for text, so also you want to know which part of the model it picks on to make a decision about the meaning. And for tabular data, similarly, basically it shows you where it's hotter, what it paid more attention. About this particular data, I think I wanted to pick on it because I think you need to make the data more in the same scale. So the first thing, if they just fit the data as is, I would say that that's the reason that the top line is the hottest one. But,
You mean normalize it.
yes. Thank you. And now fairness in the data. So this is where you want to treat, you want to basically, you don't want to have bias in your system, and that bias can come from anything. It can be the bias, our word is inherently biased. So you want to, it's not that it's always bad, because sometimes you want to really pay attention to some minorities, or somebody needs a little bit, someone needs a little bit more, but sometimes these biases is actually adverse and make the outcome unfair and unjust to some people. For an example, imagine that you have this application that determines if again, if you can get a loan, and as one of the information that it gets, it gets your location, and it uses your location, which is supposed to be a security measure to make sure that you are the same person that you say you are. Instead of using that, it uses it to say whether you are worthy of getting this loan. So then it's a huge problem. You don't want to have, you want that person to be just treated based on their credit score, or like their income, or other relevant topic, rather than something which is really far from the truth.
It's just so frustrating that these inequities like are already systemically existing, and then the AI being added onto an already problematic situation just like leans in and reinforces it, because the input that it gets is already biased, and so it just like then ultimately and I think the other thing that I was alluding to earlier with like how quickly everything is changing right now, like if you want to find a photo of an actual real thing in Google image search, then you better like set the filter to show only images before 2023. Because if you look at images that were created in the last 3 months, you have no idea if they're real or if like an AI like Midjourney created them. And so if you want like an image that's a truthful image, just like search for before this year, basically.
Well, that's part of why ChatGPT is like trained on this older data set, because like once it starts pulling in the Gen AI age, it's like a feedback loop.
I think that's
creating its own
a real
outputs.
problem is like from the earlier versions of ChatGPT, they were vastly expanding the training data and the computing power, so that the difference between GPT 2.5 and 3 was massive, and 3 to 3.5 massive, and then we like blew our minds with this most recent jump. But now I fear that there's like less data available to make it even smarter. It's basically like going to tap out at some point, and then it'll only start regurgitating the data that was produced by AI. So that's not trustworthy anyway. Because as you said, there's going to be like bibliographies at the end of the thing from books that do not exist and that haven't been written, which is like very problematic.
I think that's the reason that it's always necessary to have human in the loop, because otherwise there is no way that you can monitor the system and make sure that this does what it's supposed to do. If you take human out and you think that everything can be automated, you are really doomed with bad AI in early future.
I also was thinking it's a little different from calculators. I mean, but I'm glad you brought that up, because calculators do the same work that you do on paper. They just do it faster. But if kids are all using AI to write, then it's going to sort of regulate human output in a way where the AI model becomes in charge of what humanity produces, and only what's within the parameters of AI gets produced anymore. And innovation can go away if everyone's used to using AI to produce output, and then even if they edit it, it's still, if all images and everything becomes AI produced, then the model is circumscribing human output once it's created.
I was having a similar thought process recently, but then the other thing I was thinking is like, you can ask the bot to give you an answer, and maybe it gives something that a person with a trained eye could look at and be certain that it was generated by the bot, right? Like they could say something about it. It's like clearly a bot wrote this, not a person. But then you can also be like, can you please like restate that whole thing that you just said in a different style, like not so it doesn't sound like a bot, so it sounds like something else. And it really does have a good sense of what's different from what it just said, and it can produce that too. So, I just think that somehow the breadth of knowledge, or that it's been trained on, allows it to be consistent and also to decisively be different than that if prompted to.
I read something the other week where like I asked it to write some code for Google Cloud for me, and it said do it this way, and then I said that's not accurate. It's like, oh yeah, you're right, that's wrong. Here, do this. I said,
Okay,
that's
well,
wrong. And it goes, oh yeah, you're right, it's wrong. Here.
I will say that this is the way that all the bots universally behave is a little frustrating in that if you talk to a person, like if you and I have a conversation, you ask me something, and I'm like not that sure about it, it will be apparent from my delivery that there's a sense of unsureness in me. And like when I am sure about something, it'll be apparent as well. The bot will always answer like it's utterly sure and correct. And then with zero prodding, with basically just be like, no, everything you said is just wrong. It'll be like, oh my gosh, you're right. I am an idiot. Why did I even say that? And it'll just backtrack completely. And I wish that it would include how uncertain it is in the response. It should be like, you asked me something that I really don't understand, but I'm going to struggle to give you an answer. Here's an answer. Instead, it'll be like, here is the correct and absolutely correct true answer that you should go with. And you're like, wow, none of that is true. So I think the bots do a poor job of letting the user know how really sure it is. And these models, they do know. Like when you put an image into Google and say, is this a shoe? The model produces a value that's like, how sure is it that it's a shoe? And like, so I think the bots need to get better at being like, I don't really know, but here's an answer.
The Bard does a better job. In Bard, it'll say like, oh, here's 3 other things I thought about.
Yeah.
ChatGPT doesn't do that. But anyway, maybe that's the end of our tirade. But.
Yeah.
I think it really requires human input to make sure that how certain it is, because that's another value that you are expecting your model to predict, that, okay, if I produce this answer, then this is how much I can be sure. The model by itself doesn't know that. And what you are suggesting about images, that also is based on the human input that they retrain the model that, okay, if this is this much, then you are this much certain, you know.
Yeah.
So I'm hoping that we get, I'm so much hopeful for the future of AI. Okay, yeah. So the type of data biases. Bias is not essentially bad because, as I mentioned, sometimes, first of all, your data is inherently biased, and sometimes you want to inject bias to be fair to everybody. Sometimes the data distribution is biased, or data representation is biased, or the person who does it is biased. So it's everywhere. From the moment that you get this data, you collect this data based on where you are trying to collect the data, the person who labels them. So another interesting example was, um, how do you decide on somebody's complexion, and when do you call it darker and when do you call it lighter? Who makes this decision? Like, it's really subjective to the person who's labeling the data, and it can impact the outcome of your model. Training based on the metrics that you are choosing, and all of your feature engineering is biased. It's the human deciding it. User data filtering, ranking, aggregating. Basically, from the beginning to the end, the way you collect the data, you treat the data, you build your model, you explain what the model does, and you make a decision based on the outcome of the model. All of it can be biased. So be aware. And that what if tool that I initially explained, that's a really easy way for seeing these biases and seeing how your data reacts and making changes. So the easiest change is, if I change this particular feature, does it make a change in the decision that I'm making about this point? So let's go back to that loan example. Everything as the credit score, the income, the everything about the person, the job, everything is the same. If I change the location of their house, does it change the output of my model from giving it a loan or not giving it a loan? That can show you what your model thinks, and this is a really great tool for making these sort of changes. And obviously it gives you all of these attribution values, which equivalent of that attention map, how hot, how responsible a particular feature is in the decision that was um, basically arrived at.
So I just wanted to throw out one more thing,
Yes.
just very quick side. I just think it's kind of it's missing from the deck that they gave us, which is also just the ethics of some of this. You know, when you're making this stuff, you might want to consider. And just a quick example I wanted to give is we did a study jam like 3 years ago. We used the AI vision model, and it classifies people, right? Well, Google is very careful about this. So there was some in the training set there where it was a picture of a rabbi, but it never said rabbi in the output. It never said Jewish person. Like, they were very careful what they didn't identify, because now, do you want to give someone a tool that they can just point to someone and say, are you a Christian, a Muslim, or a Jew, or something like that? You know, you also want to think about, what should your model output, and what could ramifications of that possibly be? So they didn't really say that here, but sometimes you'll see, especially in Google stuff, they intentionally don't provide certain outputs because you can think about how it would be abused. Even in ChatGPT, if you said, how do I poison this guy? It's going to say, oh, I can't answer that question. If you ask Alexa where to bury bodies, they had to fix it, but it won't tell you where to bury bodies anymore.
Right.
So sometimes you also just want to think about with these models.
And I mean, in I think it was the recent blog post from ChatGPT that I shared, but they were talking about how, like, the purpose is to give you, like, information about the world. So, like, knowing about a president is part of that, but knowing about, like, a private individual is not. And so they had to make sure to, like, get stuff out that would reveal, like, information about personal, where you could search for something and, like, identify a person in the model, because they don't want it to do that, even though without the attention to that detail, it would absolutely do that, and it would absolutely generate those answers. And, like, for all of our best interests, I think trying to make these tools hopefully serve good and not evil is how they're going to succeed. If, like, they all just are evil, then probably we won't last very long with all the AI stuff. So yeah, it's a critical part of these to understand where you're introducing the bias and then to do the hard work of trying to reduce or eliminate it.
Definitely. So sorry, I lost my thoughts. I want to add one thing to what you said about going back to the initial data, because it opens this other field of, I think, AI work, that how you retract personal information from your data. If you are working with medical data, it's really easy to just having the model as its own. So without any data, just by throwing information to the model, identify what is the input data. And when you are working with the model which was trained on basically privacy or sensitive data, you can use it to identify information about certain people. So that's actually a really giant market for itself to find the best way to retract personal information from the input data. So that was a great interesting point for that. Okay. Okay, another reason, another part of this bias that can happen is when you do not have a balanced data set. So we discussed this example that if you have a model which seen one category 99% and another category only 1%, your model is actually predicting everything with 99% accuracy if it categorizes everything as a majority and totally ignores about what is happening with the minority. So this tool that Google provides gives you information about what is the count, so you can determine whether your model is just seeing one category more than the other.
Sorry, in that example you just had, how would you choose that? Would you say like sample 500 random data points from the larger data set? Or how would you adjust for like a data set like this one that's heavily biased in the input data source?
I would go something in between.
Okay.
Because I mean, me as a person, I'm not sure that's the perfect right answer. But because if you go with 492 and just limit your data to 2 times 492, one from the majority and one from the minority, you are immensely decrease the size of your data set. Okay. So your model would not be able to do a good job. But if you keep some of your majority and then increase the size of minority by doing some sort of augmentation, then you kind of have this sweet middle as well.
Gotcha. Okay, thank you.
We can create a baseline, right? Then we will establish a baseline where with the present data set, this is should be the results, because even if we augment, we don't know whether that augmentation will be correct.
I agree with your point that we can augment the data, but so prone to overfitting. So this bias, as we discussed, can be just bias word.
Would it be overfitted or would it be biased towards the larger data?
If you are keeping it as is and you keep the majority, like the bigger value, so you have a function tries to make it perfect for the majority because it sees it to decrease both of them to roughly 500 data points, because you go through all of overfitting to everything. And there is, because we talked about overfitting, we have done enough of training, which never happens. I haven't seen it ever in my life. It's like, anyway, so we can trying to just because it's like 7. Unbiased. We can have an simply because we do not see everybody in them. We do not have enough of representation from every group, or we can have something that is naturally happening. So transaction, how many fraudulent credit card transactions it would be just, and that's the example that I explained to you. So if your majority is 95%, if your majority is way bigger than your minorities, then your model tends to just make them everyone, because the final accuracy would be still good. The model not doing a good job for the minority. So in this scenario, the true labels are and the predicted labels are horizontally.
So we're seeing the Kahoot here. Actually, I'm going to go back and share just the slides. 1 second.
So the question was, basically, Vertex AI Workbench provides 2 Jupyter Notebook-based options for your data science workflow. This basically notebook are deep learning virtual machine image instances that are heavily customizable and are therefore ideal for users who need a lot of control over their environment. And the answer was user managed notebook instances, simply because it's a Jupyter online on the Google Cloud.
Yep.
Do you have anything to add? Yep.
Yeah, so I should be able to say next. 1 second here. So we'll advance the next question, and then we'll take the Kahoot again. So
the data used to train a model can originate from any number of systems. For example, logs from an online service system, images from a local devices or documents scraped from the web. Which of the following is the best practice for preparing and sorting unstructured data, such as images, audio, and video? BigQuery, Google Storage, Bigtable, Cloud SQL.
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 So we'll give you like 30 seconds to think about this, and then we'll kick it over to the Kahoot, so you can vote. I think this one's a short one, so we'll just.
Yeah, this one we don't need as much time.
All right, so time to vote. Oh, and by the way, the person in the front right now is Sama, followed by Audrey and Alex. By the way, the speed at which you answer it also gives you more points. So here we go.
A is red, B is blue, C is orange, and D is green. I don't know what that is.
This Kahoot crashing too. Wow, it's not our day.
Yeah, we're a technology focused group here, but we struggle a little bit with technology.
Well, it says B was our number 1 answer.
Oh,
Yes.
that's great.
And the right answer is B, which is Google Storage. And the cue for that is we are working on unstructured data. And if it was a structured, then you wanted BigQuery. And I don't know enough about the other
I mean,
ones.
literally, every one of the answers is a structured database except for answer B.
Yep.
Correct. Yeah, it's really only one way to look at it.
Okay, third question.
You work for a maintenance company and have built and trained a deep learning model that identifies defects based on thermal images of underground electric cables. Your dataset contains 10,000 images, hundreds of which contain visible defects. How should you evaluate the performance of the model on a test dataset? Calculate the area under the curve AUC value, calculate the number of true positive results predicted by the model, calculate the fraction of images predicted by the model to have a visible defect, calculate the cosine similarity to compare the model's performance on the test dataset to the model's performance on the training dataset.
So I'll open this up to voting here. And our last, after our second question, Andre is running away with it. Alex behind that, followed by Charlie.
Are the colors still clear? Do we need to communicate that again?
A is red, D is green.
Okay.
So go ahead and vote, y'all.
Well, I'm excited to hear what the answer to this one is. Does this mute the microphone, this button right here?
We're not using it.
Okay, so we have a good, I think, community that picked A, and the answer, the right answer. Sorry, how that one goes? Next one. Okay, the answer is A, but before I get to A, I want you to think about the last question, which is the cosine similarity, and that's you should just no-brainer throw it out. Cosine similarity is a distance measurement usually used for embedded space that you want to know what is the distance between two prediction. So they just throw it out there for you to make you confused because you would
So
be
it
like,
is a real concept. It just doesn't apply in this
Yeah.
situation.
At all.
Because here we have like a binary state, right? As opposed to like a distance or.
it's for prediction and they measure the, I can't explain it.
Sure. Okay.
So you have embeddings, and these embeddings are multidimensional, basically a space. And instead of like something like a Euclidean distance, you try to see what is the cosine distance between them, which is when you shadow it on the one vector, which is the worst way to explain it because I know things I cannot explain. Anyway. So the answer to this, the key to answer to this question is just to look into the numbers. And this is what we discussed before. We have 10,000 images, 100 of them is faulty. So basically the negative, the minority that we have is about 1% of all of the images that we have. So if our model totally forgets about them and makes a mistake, we are 99% accurate model, right? So they calculate the number of true positive because it gets the absolute number, or calculate the fraction of images predicted the model to have a visible defect. Both of them are looking into the absolute number. That fraction would be really small, and that absolute number of positive value would be also small. It doesn't give you a feeling of how you are. It's not accurately represent how your model is doing. The only thing which is scalable and it's not sensitive to the number and the population of your data set is the area under the AUC curve, which is looking into the area between the true positive and true negative. So that curve. Yes.
In case the option B was something like calculate the percent or the true positive rate, could that be an option if it was true positive rate as such? So that we accommodate for the scaling parameter of it. Because we're counting.
The thing is, what you are saying is, so what are you calculating that true positive? True positive rate as the true positive over true positive plus true negative, then it would be a really big number because that true negative is a small number. The only thing that I can think of, which is not a true positive rate, if you basically normalize the system and then compare how many of those normalized value you predicted correctly. Because as long as you are just going with the numbers, any combination of the recall, accuracy, all of those, they are sensitive to the majority size and the minority size, and your minority is really smaller than from, I think, an engineering point of view, you discard 1 in comparison to 10. So this number is like absolutely 0.
So we'll advance. Let's see who did the best here. Remember, A was our top answer, so a lot of folks figured that one out.
Good.
And pulling ahead now, Andre ahead by 200 points, followed by Alex, and then Rob. Rob has moved into 3rd place. Oh, crap. So sorry. I opened it too quickly.
So you are an ML engineering at a media company. You need to build an ML model to analyze video content frame by frame, identify objects, and alert user if there is inappropriate content. Which Google Cloud products should you use to build this project? Pops up in all of them. Okay, they answered already.
Let's use pops up.
I timed out the ability to answer.
Oh yeah, we ran out of time.
I'm sorry.
That's okay.
So let's walk through it then.
So all of them have pops up. So that's basically what it is. Yeah, doesn't discriminate. 3 of them have cloud function. But I think the key here is the video intelligence API. And in the course, it also explains that this video intelligence API is basically this API to tell you if there is an inappropriate content, anything that shouldn't be there. So that's like the giving away the answer by its own.
So what about AutoML video intelligence? Why wouldn't you use that?
I don't think that exists.
Isn't AutoML is like just does image analysis, or it doesn't do image analysis at all? Like it's just like logistic regression.
Yes.
Or is it even a thing? It is a real thing.
I don't think so. I don't think that AutoML to the best of my knowledge, it has for images, for text. I don't think that it has a video. I'm not sure.
We were debating that earlier, whether Google sometimes put answers in that don't exist.
Yeah. Okay.
So,
A sarcasm detection model was trained on 80,000 text messages, 40,000 messages sent by adults 18 years or older, and 40,000 messages sent by minors. The model was then evaluated on the test set of 20,000 messages, again 10 by 10. The following confusion matrix showed the result for each group. A positive prediction signifies a classification of sarcastic. A negative prediction signifies a classification of non-sarcastic. Choose the correct answers. 2 answers are right. And so the answer A is 10,000 messages sent by adults are a class imbalance data set. So look at the adult and minor those precision and recall. So precision is true positive over true positive plus false positive. So everything that the model picked as sarcasm, whether the right ones over everything that it picked, and the recall, which is true positive over true positive and false negative. So what model picked correctly from the sarcasms over all of the sarcasm that existed. So that's that. Again, A is 10,000 messages sent by adult are a class imbalance data set. The model failed to classify approximately 50% of minor sarcastic messages as sarcastic. The 10,000 messages sent by minor are a class imbalance data set. Overall, the model performs better on examples from adult than examples from minors. So can we go to Kahoot?
Yeah. So now we'll open up for voting. This is the 5th question, right?
Yes.
So let's see who's going to take the win.
How do we select 2 answers?
So red is A and C. Blue is B and C. Orange is A and B. I'm sorry, I didn't know that we cannot. Yeah. Green is C and D.
So again, red is AC, blue is BC, yellow is AB, and green is CD. Got 30 seconds. What I don't get is I'm sure that old people are more sarcastic. Like, I know I am.
Have you met young people recently?
All right, maybe.
That itself is pretty sarcastic.
But really, like, adult range is like from 18 to dead, and then children like are still developing language skills. So I just feel like it's not a good sample.
Shout out to the person who picked A and B, which is the answer. So the 10,000 messages sent by adult are a class imbalance data set. And if you look into the true positive, false positive and true negative, false negative, and you sum them. So you basically have the total number of positive and total number of negative, which shows that the number of positive that you have is significantly lower than the number of negative you have. So basically, the model was trained to say that adults are not as sarcastic. And the model is, so that's the first one and why it is right. And the second one, the model fails to classify approximately 50% of minor sarcastic messages. So go back to the minor, basically confusion matrix. You see that true positives are about 2,000. False negative, which is immediately under that, is also 2,000. So from the total number, it basically gets 50% are sarcasm and 50% are not sarcasm. And this is the reason that these two are right. 10,000 messages sent by minor are a class imbalance data set. This is not essentially a imbalanced data set because so when you add the number, it doesn't look, it's like 5,000 and 5,000. And overall, the model performs better on examples from adults than on examples from minors. This is not right because the model is biased. So you cannot make a decision just by precision and recall. It is really biased toward the number of positive and number of negative. It doesn't represent all of the data. And that's it.
So let's see who our swag winners are. So let me bring our podium up and share it on the other screen here. So number one, the winner is Audrey.
Amazing. Congratulations.
Are they here or?
Is Audrey in the room?
Because we need the rest of them to know who to give them.
So I'm just trying to get this on the other screen.
Is anybody
Yeah.
among the winners?
Okay.
That's convenient for us because I'm not shipping.
Yeah, so unfortunately we don't have shipping, so
We had an event in January, and we had one of the GDG organizers who's from Africa joined and told all his friends to join, and they all joined, and like one of them won a large Google speaker, and then like there was no way for me to ship this thing to Africa. We ended up, I had to buy like a eBay gift card and then take a picture of the gift card and send it to them, and then they bought something from eBay through a reshipper that would then like, and it was just so
sketchy.
So we are doing in-person swag gifts from now on.
So who is number two? Who is Wow? Is Wow in the room? Wow is not in the room. Okay, sorry, Wow, but thank you, great job. And Alex is over here, so Alex can have a swag set up here. And see, do we have the overall list of people?
Oh, that is a mug. So I basically put together 3 little swag kits. One is a mug, one is a bottle, and one is a hat. Yeah, please look at the mug. International Women's Day.
They won't tell us who the rest of the people are. You gotta pay extra for that.
Oh man, we can't. So we'll just have people arm wrestle or something.
We'll have it. Yeah, arm wrestling. You'll be arm wrestling. Okay. 1 second. Let me.
We have second place in the chat, but I don't believe they're here physically.
So we're gonna view the report. It says we shouldn't view this in front of other people. I don't know why.
Oh, because it has all their personal details.
All their personal details.
Socials.
So sorry. Our fourth place is Cassava
Cassava, 4th place.
in the room. No.
I am remote. I'm
I
remote.
see
Is Rob in the room?
unmuting
Okay,
himself
Rob,
there.
come on down.
Amazing.
And,
so this is all the more reason for folks to consider joining us in person on the next event, because you will have the opportunity to
Okay, there's
potentially
nothing
walk
personal
away
in
with
this.
some
I don't know why they won't want.
very
Mike, is
exclusive
Mike in
swag.
here? Mike, no.
Mike is not
Sama?
physically present.
Sama, come on down, Sama.
All right.
All right, thanks for playing there. Apologies, that was a little more rough, but right before the meetup tonight, we went and bought a pro account. So next week will be much better. This is just, there's a lot of limitations in the free account, which we will not be using anymore. We just went and bought it. So next week will be much better.
Could you stay on that slide for a minute?
Sure.
I just want to point out, if you work in healthcare with medical testing, these things are extremely common. This is called confusion matrix, or sometimes just simply 2x2 matrix. And there's a field called clinical epidemiology that discusses all this stuff, and it's like recently I got to be a PCP doctor, and he's actually trained in public health, and he's talked to me about number to treat and number to treat, things like that. And it's like, and all that comes out of this kind of theory, and I'm surprised to hear talking about that. And I said, look, I am probably one out of 100 patients that actually understand what you just said. And so, it just give you an example. If you think about COVID test, we know about the quick home test, which is not as accurate. And then we have the, so when you set up a matrix like this in healthcare, you have a new test that you're evaluating. Let's say it's the COVID home test. What's your source of truth or your ground truth? Well, that's your gold standard would be the PCR test that you would have run over the road. If you sent your sample in and went through that, waited for 2 days, got your result back, that would be called the gold standard because it's like super accurate based on PCR or nucleic acid amplification, right? But you'd set up this kind of matrix. And so there's a whole, this is really relevant for any kind of healthcare stuff. And then also I just want to point out the history of the AUC curve is very interesting in itself. The earliest use of it that I know is in late 30s in Britain when they were setting up the radar system called Chain Home, which is all along the east coast of Britain. They set up, radars were not these small things that they are now that were really high quality. They were really crappy, low quality signals, and the towers were these giant things that had wires strung across. And the little blips that you have this sort of really noisy signal that was called grass. And you would have this like, oh, there's a little blip. So is that an airplane or is that just nothing? Is that more noise? And so you had to then say, well, how tall was the blip above the baseline noise, the grass? And then you would create this AUC curve from that, and you would say, okay, well, based on that height of that blip, the probability that there's an airplane is 30%. And if it was higher, it would be like 50%. If it got to be high enough, it would be like, oh, 90, that's definitely an airplane. It's coming at us, right? So those are the Brits were really good at integrating science with the defense of their nation in the 30s. It's a very interesting period of history that I've read a lot about. So that's where the AUC comes from, as far as I know. Goes back, it's not a new concept at all, very old.
Just throw in one sentence when you think about why these curves are important. If you're making a home COVID test, would you rather have false positives or negatives? Would you rather have false positives? You tell them they had it when they didn't, and tell them they didn't have it when they did.
Yep.
You know, things like that.
Yes, and there's a whole art to determining like where do you want to be on the AUC curve, where do you want to set your cutoff point as to where, like Joe said, sometimes false positives are much more costly than false negatives. So you depending on how you're using the test, you want to set your set point at the right place, but it's all based on the AUC curve.
Are we doing the last or?
I'm not. I mean, it's already 7:40.
I think we had more fun talking.
Yeah, I think we're
Really.
good today.
We had great discussion today.
There was you weren't looking at the chat because you were busy presenting, but there was a lot of feedback from people in the chat that this was like a very highly rated session for them due to not the slide portion, but to the discussions we were having and the questions we were answering and all that. So
Nice.
I think people got more out of watching us talk about the problems than they would have about watching us click through the lab, which they can totally do on their own.
Mhm.
And this you can't do by yourself at home. You can only do it amongst a bunch of people. So a lot of positive feedback about that.
That makes my day. Thank you very much. So for this week, we will be launching into machine learning and TensorFlow on the Google Cloud. It's a lot of dealing with data frames. If you are familiar with Python, it's a lot of pandas, NumPy, and TensorFlow. Please reach out if you have any question. I was prepared to go through one of the labs, but we didn't have enough of time. But essentially, if you are familiar with the Jupyter Notebook and Python, this is the same thing, basically. Yeah. And with that being said, I think we are just coming back next week.
Yeah, we're just.
do you not get,
I guess I'll
like,
just
an
interrupt
email
everybody.
about
Make
the
sure you
credits for the
sign up for
days?
next week, right? Just sign up for that, especially if you're remote, because if
So
you didn't
you
sign
were
up,
the
you
first
can't
week, right?
log in to watch
Did
it.
you get the credits?
Sign up for all of them.
Sure, sign up for all.
One thing that I don't forget to say, for all of the Jupyter notebooks, there is a lab and there is a solution in the same, basically in the same folder. So if you get a start, because some of them are questions that if you haven't been working with pandas for a while, you don't know immediately. So please look at the solutions. It's for you to learn. It's not for you to judge yourself and say, hey, I don't know. It's a good way of learning things. So that's
I'll say
it.
thank you, Ms. Roya, for all the presenting.
Yeah,
Thank you very
thank
much.
you.